Hi, this is Mr. Shumway. This video clip explains how to estimate the number of wildlife. This is one method. Let's say the Division of Wildlife Resources nets 40 fish in the 4th reservoir and tags them and lets them go. And later nets 30 fish, and 2 of them have been marked previously. They might conclude that there are blank fish in 4th reservoir. Well, would you agree that if we tag 40 fish of the whole lake, that 40 compared to the whole number would be the same as those that are marked out of the 30, or out of the 30 that we catch? So the ratio of marked fish to unmarked to the total fish caught, would you expect that that would be the same in the whole lake if this sample represents the whole lake? And there's no guarantee that it represents it well, but we'll say we netted a representative sample. So then all we have to do is solve that equation for x. Well, to get x out of the denominator, I'm going to multiply both sides by x. X divided by x is 1. And now I want to get rid of the 2/30ths. I could multiply both sides by 30 halves. Thirty divided by 30 is 1. 2 divided by 2 is 1. So now on the left we have x equals, well, 30 times 40 is 1200. Half of 1200 is 600. You can just put that in your calculator if you want. Or you could say half of 30 is 15. 4 15s is 60. So 40 15s is 600. So let's do that same thing with grouse. Say we catch 50 and tag them and let them go. And then later we catch 40 and only 4 of those are marked. So 4 out of 40 we would expect would have the same ratio as 50 marked ones compared to the whole population. We would expect that the marked compared to the unmarked to the total would be the same in both cases if our sample is representative, and we will just assume that. Multiply both sides by x, solve, multiply by 40, divide by 4, multiply by 40, divide by 4, and we have 2,000 divided by 4 would be 250. Oh, no, it would be 500. Well, that's easy. 40 divided by 4 is 10. 10 times 50 is 500. All right. I missed a simple one there. And that same idea is used on any surveys. They assume that that ratio holds for the whole population and try to estimate. That's why they say there's estimates for a lot of statistics, because they haven't counted everybody, but they've counted a small sample and assume that that applies to everybody else.